Have you ever just stared at a loading screen and wondered what on earth is going on with your network? Well, today we're going to pull back the curtain on those slowdowns. We'll get into the nitty-gritty of the systems that make our digital world tick. So let's just dive right in. Ah, yes, the classic question. Why is my network so slow? It's enough to drive you nuts, right? And the truth is, there's no single simple answer. It's actually a mix of different things. And by the time we're done here, you're going to know exactly what those things are. Okay, so to get to the bottom of this, we need to look at 5, let's call them key factors that really affect your network's performance. Think of them like the 5 main suspects in a mystery. All right, first suspect on our list, bandwidth. And right away, we have to clear up a huge misconception. People think bandwidth means speed, but it's not. It's all about capacity. I love this analogy. Imagine you're drinking a thick milkshake. A skinny little coffee stir, that's low bandwidth. A huge, wide drain pipe, that's high bandwidth. The milkshake itself doesn't move any faster, but with the drain pipe, you're going to get a whole lot more of it a whole lot quicker. It's about the size of the pipe, not the speed of the liquid. So bandwidth is just one piece of the puzzle. We've got 4 other culprits to look at. First up, the sheer number of users. I mean, imagine a bunch of people all trying to drink from that same drain pipe at once. It's going to slow things down. Then you've got the transmission media itself, what the network is actually made of. A fiber optic cable, that's like a brand new superhighway. An older connection, more like a bumpy country road. And what about error rate? If your connection isn't stable, data has to be sent over and over again. It's like having a bad phone call where you have to keep saying, "What? Can you repeat that?" Super inefficient. And last but not least, there's latency. That's just the raw delay, the time it takes for data to physically get from point A to point B. Okay, so now we know what makes a network slow, but let's zoom out a bit. How are these networks even built? What's the blueprint? Well, it turns out pretty much every network you'll ever encounter is designed in one of 2 fundamental ways. And you can really boil it down to this simple idea. You've either got a network with a central boss in charge of everything, or you have one where everybody's an equal. That's it. One has a leader, the other is a team. And these 2 blueprints have names: client-server and peer-to-peer. So let's tackle the first one, the model with the central boss. This is the client-server network, and you've definitely used this because it's the backbone for most big companies and a ton of the online services you use every single day. The whole idea is pretty straightforward, actually. You have one big, powerful computer, the server, and it's in charge of all the important resources, the files, the security, you name it. All the other computers on the network, the clients, have to make requests to the server. Hey, can I have this file? Can I use the printer? That library analogy is just perfect. You can't just wander in and grab a book off the shelf. Nope. You have to go to the librarian at the central desk and ask for it. And the upside to this? Well, it's all about control. It's about order. When you have that one central librarian, it becomes so much easier to manage things. File security? Check. Centralized backups where everything is saved in one safe place? Super simple and reliable. Pushing out software updates to everyone at once? A piece of cake. It's just neat, efficient, and very, very organized. Yeah, but all that control and organization doesn't come for free. Not at all. First off, servers are expensive, and you can't just have anyone run them. You need specialized IT folks who know what they're doing. But here's the real kicker. The biggest risk of them all, the server is a single point of failure. Think about it. If that librarian gets sick and goes home for the day, the whole library shuts down. It's the same thing here. If that server goes down, the entire network can just stop, dead in its tracks. So if that's the boss model, what's the alternative? Well, let's shift gears and look at the other blueprint, the decentralized one, where everyone is equal. This is the peer-to-peer model. You might have heard it called P2P. With peer-to-peer, you just throw that idea of a central librarian right out the window. There isn't one. Every computer, every peer is totally equal. They talk to each other and share files directly. And that book club analogy? It's spot on. It's not a library, it's a club where everyone brings their own books and passes them around to the rest of the group. No middleman. And you can see the benefits right away, can't you? First, it's way cheaper to set up. Why? Because you don't have to buy a big, expensive server. It's also way easier to maintain. You don't need a whole IT department. And maybe the best part? No single point of failure. If one person decides to leave the book club, does the whole club fall apart? Of course not. The rest of the members just keep on sharing. The network is resilient. But you know, all that freedom and flexibility has a flip side. There are some real challenges. Security is probably the biggest one. With no central boss enforcing the rules, things can get a little Wild West. Also, every single person is responsible for backing up their own stuff. If your computer dies and you didn't have a backup, tough luck. And just keeping things organized can be a nightmare. Without that central card catalog, trying to find a specific file can feel like a treasure hunt when it could be on literally anyone's computer.
So there you have it. Two totally different ways of building a network. But before we start debating which one's better, I want to bust a really common myth. A big misconception people have about how peer-to-peer networks are physically wired together.
This chart really lays it all out nicely, doesn't it? On one hand, you have client server, expensive, needs experts, but you get that tight, centralized security and easy management. On the other hand, peer-to-peer, cheap, easy, no single point of failure, but everyone's on their own for security and backups. It all boils down to that fundamental trade-off. What's more important to you, tight control or low cost and simplicity? Okay, so back to that myth I mentioned. When you're on a P2P network, it feels like a direct connection, right? Like there's an invisible wire stretching from your computer to your friend's computer. But is that what's actually happening with the physical cables?
So this is what we call the logical view. It's how it seems to work from your chair. From your point of view, your computer is just having a one-on-one chat with another computer to send a file. It feels direct. It feels, well, peer-to-peer.
But, and here's the big reveal, that's not how it actually works physically. In reality, all those computers are very often wired into a central box, a switch or a hub, just like in a normal office network. So the magic isn't in the wiring at all. The magic is the software. It's the protocol that creates that direct peer-to-peer feeling. It makes the network act decentralized, even if the physical wires all meet in the middle. So, after all that, we land on the big practical question. Which one is right for you? Which blueprint should you use? And honestly, there's no single right answer. It completely depends on what you need. If you're running a big company and you need rock-solid security and central control over everything, client-server is the only way to go. It's the clear winner. But if you're just setting up a small office or even just your network at home and your main priorities are keeping costs down and keeping things simple, a peer-to-peer network is probably the perfect solution for you. And that brings us to one last, really big question to chew on. When you look at all the new technology coming out, things like blockchain or the Internet of Things, where everything from your fridge to your car is online, which direction are we headed? Are we building a future that's more centralized, with a few giant companies controlling massive servers? Or are we moving toward a more decentralized world, where billions of tiny devices all talk to each other directly as peers? The answer to that? Well, that's going to define what the internet looks like for years to come.